Hi, myself Naveen Kumar Saini. In the course Microprocessor, code KCS403. Today is the lecture number 1, where we will discuss about microprocessor architecture and operations of its components. So first of all, we must know, must introduce the concept behind the microprocessor, what is that and what is the operations. So before that, it must be very clear to all of us that microprocessor is nothing but this is the CPU. Okay. Or the central processing unit. So it's a complete computation engine that is fabricated on a single chip. So this microprocessor is generally used for the processing of the informations or the data. So wherever the data is to process or the program is to written, where at that point microprocessor is required. So the first microprocessor, it was Intel 4004, which is introduced in 1971. Okay, and it was the first microprocessor, and but it was it's also a 4-bit of microprocessor. But in the initial days, it was not very powerful to execute or to operate more number of instructions, but it was used generally to simple instructions like addition and subtractions. Okay, so why, and this one is only for 4-bit of microprocessor. We call it as the 4-bit microprocessor, first microprocessor which is developed by the Intel. Here before to 4004, these engineers built computers that was nothing but the collections of chips. Okay, and it was discrete components was mounted onto the single chip. But when this 4004 Intel microprocessor came into the picture, it was only onto a single chip. So that is why we call it commercially available first 4-bit microprocessor, or the first generation microprocessor was 4004 Intel microprocessor. So by the definition point of view, we must be clear about this, that the microprocessor is a programmable device, okay, that takes in the instructions and the numbers from the outside world and perform them on the arithmetic logical operations. Okay, so the numbers or the instruction which is included into the memory and is stored from the outside world, so it takes into the microprocessor and it is performed the operations by the ALU. ALU is the arithmetic and logical operations according to the program which are stored in the memory, and then produces other numbers as the result in the conjunction with the clock. So here the terms which are used, that is programmable device. So this programmable device, it shows that the microprocessor can perform the different sets of operations on the data itself, which it receives from the outside world as in sequence, and then this instructions which is coming from the outside supplies to the microprocessor, and then this and it changes or manipulate based on the in the different ways. So it is really very tricky job by the microprocessor, which execute the instructions when it fetch at the initial stage, and then decode and then execute it. Okay, so these are 3 operations of any of the microprocessor which it performs: fetch, decode and execute. So that is why, because every instruction which are fetching one by one sequentially, so that is why this is the programmable device which execute the program, and program is nothing but this is the set of instructions. So every instruction will be fetched and then decode and then execute. So here it mentioned that takes in, so the takes in, it's simply into the microprocessor. Okay, it is into the microprocessor from somewhere else. So microprocessor doesn't contain the memory, okay, except if we are talking about the previous 8085 or before microprocessors. So cache memory was not there, and that the this accept the information from the outside world. Okay, so it comes from where, that is called input devices. Okay, or these are devices that brings the data into the system from the outside world. So it's very simple way we can say that MUP is one entity, and outside that we have the input IO devices or the memories. So we fetch the data or information from the memory or from the input output devices. So that is why this wherever the program is required to execute, there is a microprocessor is required. So simple example of that one, if we have remote control, so for that remote control we require the microprocessor. If we have a fan, there is no microprocessor is required. If there is a smart fan, then only the microprocessor is required. So in short, microprocessor is a device, programmable device, which can execute the programs if it is written. Okay, so wherever we find the instructions or programs are written, there the microprocessor is required. Otherwise, there is no need of the microprocessor. So here the term instructions. So each microprocessor is designed to execute a specific group of operations. So this group of operations is called the set of instructions, and this set of instructions is nothing but the program. Next terminology which is used, the numbers. So these microprocessor have the very narrow view of life. It can only understand the binary numbers, as we know. So this microprocessor only understand the machine language like zeros and ones, binary numbers. So these binary numbers are nothing but the bit. 0 and 1 is a bit. So group of bits, call it as, if 4 groups of bits is called one nibble, 8 groups of bits is called a byte, and 16 is a word, and 32 is a double word. Okay, so in that fashion these numbers are used. So as we are very much aware that must be aware that microprocessor language which is understandable, that is assembly language. So the program which is written into the assembly language, and it is converted into the binary language by the compiler, right? So different processors or the different high level language can be converted into the machine language by using different compilers, right? So arithmetic and logical operations. So this is the part of microprocessor which performs the operations or different operations, arithmetic operations and the logical operations. So arithmetic operations, simply we say the addition, subtraction, which is a part of instruction set, and logical operations are the operations where we perform the logical AND operations, logical OR operations, XOR operations, XNOR, and so on, or here shift left, shift right, etc. So the number and types of operations which is defined by the microprocessor instruction and depends on the specific microprocessor. So that is why we call it the arithmetic operations, where the addition, subtraction is there, and the logical operations where we require the AND operation, OR operation, and so on. So here the microprocessor has multiple data types. So these data type formats are like binary BCD numbers, ASCII codes, signed, unsigned. This type of numbers can be gone through the microprocessor. Okay, so these numbers, this status can be processed through the microprocessor as well. But the one thing which we have to keep in mind, that the language which is written in assembly language, it accepts the hexadecimal numbers in the microprocessor. Next point is the memory. So memory is the location where the information is kept, okay, and while not in the current use. So memory contains the two parts. First is the programs itself and plus data. Okay, so programs consist of the instructions, set of instructions, and instruction is called the opcode plus the data. Okay, so we call it as the operand. So opcode plus operand is one of the instructions. Okay, so these two are fetched from the memory. It means it is stored into the memory from the outside world. So the values from the outside world is stored into the memory as well. So it can so in the memory is what? So here if we talk as an example of 8085 microprocessor, each memory location contains the 1 byte of information. Okay, and the address lines for that particular location is nothing but, if we have this type of memory, so in this and this is so we divide it into that way that this is nothing but the address and this is the instructions plus data. Okay, so this instruction or data 1 byte will be stored into it, and here the address depends on the address lines depends upon the which type of microprocessor we are using. Just like if we are using the 8085 microprocessor, so for that address lines which we have 16-bit. Okay, and instruction and data where we use the 1 byte of information. So if we want to store the 2 bytes of information, so it means for that we require the 2 memory locations if we have another 1 byte instruction. Okay, so these 2 byte of instruction can be stored into the memory from the outside world by using the 2 different memory locations. Okay, so here the example we have taken about a 16-bit address lines which are used in the 8085 microprocessor. So here next point, here it is mentioned that this memory is defined in terms of the kilos, megas and then gigas, where we are using that nowadays. So kilo in the computer language is called as 2 to the power 10. So this number is 1024. Okay, so 1 kilobyte, that is equal to 1024 bytes or kilobyte, and mega is 10 to the power 6, right, and giga 10 to the power 9. So these are multiple of 1000s, right. So 1 kilobyte is equal to 1024 bytes or 2 to the power 10 bytes. If we have mega, in mega we say 1024 kilobytes. So very simple, we can understand in this way. Just like 1 kilobyte is equal to 2 to the power 10. Now if I want 1 mega, just for example I am using megabyte. So here nothing but this is 2 to the power 6. You can write 1 megabyte, that is equal to 1 kilo, or you can say this is 1 kilo into 1 kilo. Okay, so this is 2 to the power 20. Oh, okay, so hope this point is clear to all of you. This is 2 to the power 20. So this is a 1 kilobyte of information, or you can say this is also equal to 2 to the power 10 into 2 to the power 10. 1 kilo into 1 kilo, or that is equal to 2 to the power 20 is equal to 1 megabyte of the 1 megabyte information. Similar to that 1 gigabyte, we can write 2 to the power 10 into 2 to the power 10 into 2 to the power 10 and 10 to the power 30. So this information we can understand easily. This is the power of 2. So in the various ways we can calculate the power of 2 when we required to find the memory locations. Clock is referred to the microchip. It regulates the timing of and speed of all the functions, computer functions. In the chip, it's a crystal that vibrates at the specific frequency when the electricity is applied, and the shortest time any computer is capable of computing is in 1 clock and or 1 vibration of the clock. And the speed of the computer with process is the clock speed. So clock speed, the definition of that one is this one is clock speed. It determines the number of operations per second. Okay, so it can be expressed in megahertz, gigahertz and so on. So this is called the clock rate as well. Just for example, if we have any laptop where we say the clock speed is 2 to the power, you can say the clock speed for this one is 3 gigahertz. So the significance of 3 gigahertz means this is equivalent to 3 billion operations per second. Okay, 3 billion operations per second. So in this way the clock speed can be calculated. So how this microprocessor can work? So there are 3 steps for calculate for operations of any instruction in the microprocessor. First one is the fetch, then decode, and then execute. So first, any instruction which is written into the microprocessor into the memory, it is first fetched by the microprocessor and then decode it and then execute. So after that the next instruction will be fetched. Okay, but during that period the program counter will be incremented by 1. Okay, initially instructions are stored in the memory as we have mentioned in a sequential manner like this, 1 2 3 like so. So these are different instructions which I mentioned here, and the microprocessor fetch the first instruction which is from the memory and then decode it and then execute those instructions till the stop is not occurred. Later the next instruction will be fetched and then execute and then decode and then execute, and the operations which are performed into the microprocessor, that is into the ALU, arithmetic and logic operations which are performed into it. So the microcomputer is made up of 3 main units. First is the ALU, arithmetic logic unit, control unit, and all the registers. So it shows the mini computer. Any of the computer is mentioned like this. Okay, so which comprise the microprocessor central part, and then around with it we have the inputs like keyboard, mouse. We have the outputs. These outputs are nothing but your display. Okay, display, your printers. So these are the outputs onto which we see the results. Then along with it we have the in the microcomputer, mini computer, we have the memory. So this memory can be of RAM, ROM, and so on. So it looks like this one, where the microprocessor is comprised of 3 parts: ALU, register array, and the control unit, and these are connected with the IO input output device and the memory, ROM, and RAM by the system bus. Okay, so this system bus is nothing but this is a combination of all the 3 buses: data bus, address bus, and the control bus. So here that the system bus is nothing but this is the comprise. First is the data bus, this is data bus. Second, this is your address bus, this address bus, and the third one is the control bus. Okay, so these combination of these 3 buses is called the system bus, where the system bus are used for transferring informations in between the computers. So here the components is specified. First is the ALU, which we have just mentioned. This ALU is nothing but arithmetic and logic unit. It is a digital circuit which present into the microprocessor, which perform arithmetic and the logical operations on the digital data. Okay. Second component of microprocessor is the register array. So register array, it's a single register is a set of flip-flops. Suppose we have one register which comprise the 8-bit register. So this 8-bit register will comprise the 8 flip-flops. Okay, small flip-flops are there which are the storing elements. Okay, so here just ALU and then register array. So these are the memory units elements, we call it as in that way, where the information, 1 byte information is stored into the memory. Okay, at the 16 bit of address lines, just like example of 8085 microprocessor, and then the programs are to be currently executed, which is information stored into the registers. Then next is the control unit. So in that control unit is used to inform to the memory or MUP that what type of operation needs to be performed, maybe the read operation, write operations by the microprocessors. Okay, so this is between MUPI and the outside memory or IO devices. Read or write operation can be performed. So this information, that read or write operation which is need to be performed, is controlled by the control unit. So in that a microprocessor architecture, as we have discussed about what type of the things we are required. So in that microprocessor unit, it is the heart, basically called the heart of the microcomputer. Suppose there is no microprocessor, in that case your microcomputer is nothing, junk of only small things. Okay, so microprocessor is the main part of any computer which performs few functionalities. So how it is defined? It provides the timing and control signals for the elements to the MUPI. Second step is fetching instructions from instruction or data from the memory. As we discussed previously, memory comprises the two parts. First is the instructions and the data, so it can be fetched from the memory. Then transferring data and from memory and IO devices. Then decoding the instructions. Decoding instructions means, suppose I want to add, right? I have the instruction like add operation. So this add is into the assembly language. So to understand this add operation, that is a decoding. So we have to decode that. Okay. So for that one, we have the different type of decoders. Okay. So this is the second step. After fetching, we have the decoder. Then perform arithmetic and logical operations, which is called by the instructions. Okay, based on the instruction, suppose we have the add instruction, then we will perform the addition of the two numbers. If we have SUB, subtract, second instruction SUB, then we have to subtract. So before performing the operation, we have to understand this decoding part of this one. Okay, so first instruction will be decoded. After that, the instruction will be performed. So responding to IO generated control signals and such as reset and interrupts. So these are the externally initiated operations which are performed to the microprocessor. It depends on the external devices. So what need to be performed? Okay, so just example they have mentioned about the reset and interrupt. So now microprocessor, in that second part of this one, the basic definitions we are aware about that microprocessor nothing but is a programmable logic device that designed with the registers and the flip-flops. Okay, so it again, the microprocessor has a set of instructions which is designed internally to manipulate data and communicate with the external peripheral devices. So the process we have already covered about the microprocessor first fetch and then decode and then execute. But what are different operations which can be performed, or the functions can be performed? So these functions are classified into the three ways. So first one is the microprocessor initiated operations or the functions. Second one is the internal data operations. And the last, peripheral initiated operations, we call it the externally initiated operations. Okay, so we will go one by one, so to understand what are the functions of the microprocessors. Okay, so first one is microprocessor initiated operations. So what it says, that what are the operations which can be performed, which will be initiated by the microprocessor as well. This is our microprocessor, this is our memory, and this one is our IO device. Okay, so as we are aware that all these things are connected with the different buses. Fine. So as we are talking about the microprocessor initiated operations, so in that, so in this case we will discuss about this one. So what are the operations which are performed which are initiated by the microprocessor. So microprocessor can perform the basically two operations. First one is the read operation or the write operation. Read operation will be from memory to MUP or IO to MUP, and this is the read operation. Write operation opposite to that. Write operation is from MUP to memory or MUP to IO. Okay. So I am not using the R bar or W bar here for simplicity only. So here the operations which are performed, first one is the memory read operation. So what is the significance of memory read? So this one is the reads the data from the memory. So here we have mentioned it reads the data from the memory. So we call it the memory read operation. Second one is the memory write operation. So this is the this operation is performed between the MUP and the memory. So it writes the data from into the memory. So it shows that the writes the data into the memory. So this one is the memory based operations between the memory and the MUP. Third one is the IO read. So it accepts the data from the input device. Okay. So this one is the read operation which is performed from IO because in IO we have to select pin for input or output. If you are selecting the pin for input, so this is a read operation. If you are selecting the output enable, in that case this is the IO write operation, sends the data to the output device. So it depends on the IO operations. IO is one or enable or disable. So based on enabling and disabling, the input or output pin will be enabled. So here we just want to mention one of the example for that. What are the steps for read operation from the memory? So in that what are the steps which follows? First is MUP identifies, so microprocessor, it identifies first the peripheral device, then it places a 16-bit address on the address line. So if, as I said, this is the MUP, this one is memory, and here, so here we have a 16-bit of the address line. So this MUP will place the 16-bit address line towards the memory. First memory will find the external device, okay, and then the MUP will send the 16-bit of address. Then external logic circuit which decode the address and identifies the memory location. So this decoding will occur into the MUP as well. It will decode where the data is to be, from where the data is to be fetched, right? Then MUP sends a memory read operation. So memory read synchronization signals are used for that case. The memory chip is activated, and then the content of the memory chip are placed on the 8-bit data bus. Okay. So data bus is used because data bus is nothing but this is the bidirectional data bus. Address bus, this is the unidirectional. Okay. So address bus direction is from MUP to memory. Clear? And the data bus will read or write. So whatever read and write operations performed, it is performed using the data bus only. So if it is a read operation, then direction of flow of data will be like this. If this is a write operation, this will be like this. So this is a read operation, this is the write operation. Okay. So these operations read and write will be defined by the controls bus. I think this point is clear. So who will tell to the read or write operation? This is controlled by the control bus. Then we have internal data operations. So in that internal data operations, first step is it will store the 8-bit data. Then it performs the arithmetic and logic operations. It tests the conditions. Then sequence the execution of instructions. It will sequencing the execution. Then store temporarily during the execution in the defined read write operations or memory locations, which is called the stack or top of the stack. So these are internal data operations which is performed into it. So example here we have mentioned here in simplified manner. I will explain this, that MVI A 50H, MVI B 20H, add B and halt. This is the main program which we have. So what is the significance of this? That MVI move immediate. Move immediate means indirect, right? So 50 is the operand, it is stored into the accumulator. MVI B comma 20H, so 20 is stored into the B register. Add B, the significance of add B is A plus B, and the data will store into the accumulator as well. So this is the here it shows that A plus B again stored into the accumulator. So if we take the 8085 microprocessor, in that the A plus B is the two numbers, it are stored into the accumulator as well. So the first number will be stored into the accumulator first, and second number will be into the temporary register, or into the register temporary register B, and it will move into the ALU, and ALU will perform the addition, subtraction, whatever requirement is there. Here the addition is there, so it will store into the accumulator as well. Okay, so so it shows here that MVI A, then memory location is shifted to here 50 Hertz, then 2002 to 2003 MVI B and 20H, and 2004 to halt 2005H. So here it requires one memory location because MVI is a 1 byte instruction. A again 1 byte, so this will store 50H, and then again 1 byte is 1 byte, again 1 byte, and so on. So every 1 byte will comprise the 1 instructions, 1 memory location, as we mentioned. Last, peripheral initiated operations, where these operations are initiated by the peripheral devices connected to the microprocessor or the external devices. First is a reset, interrupt, ready, and hold. First is a reset pin. What if the external device will reset the pin at 8085 microprocessor? So what will happen? Complete program will be cleared and memory location will reach to 0000H location, and then after that the execution of the program can begin from the memory location at 0000, right? So these are reset operation. Next is an interrupt. So these interrupts are given externally by the different pins of 8085 microprocessor. So these pins are 5.5, 6.5, RST 7.5, and the trap. Trap is of highest priority. So these pins are used externally, interrupt and to interrupt by the external things, and then the microprocessor operates that other program which is interrupted by these pins, and we call it as the service routines. Okay, and after completion of service routine, it will come back to the main program. It resumes to the main program. Then the ready pin. So this ready pin is the pin in 8085 microprocessor which is used to keep microprocessor at the wait state. Okay, so the input output devices that are connected to the microprocessor are different speeds, so which is need to be synchronized with the speed of the microprocessor. So these signals mainly need to synchronize with the slower external devices of the microprocessor. Okay, so slow peripheral devices can be communicated to the using microprocessor buses. So for that one, the ready pin must be enabled. Last, hold signal. So this hold signal or hold pin of A8085 is activated so that the IO device directly can communicate with the memory without the intervention of the microprocessor. Okay, so in this way, this external pin again can be used. You can say that these are the externally initiated operations to the microprocessors. Okay, so first one was the hold, and then ready pin, interrupt, and the reset. So all these four are the externally initiated peripheral devices pins to the microprocessor, so that the operations can be performed easily. So I hope this complete architecture of microprocessor and its operations are clear to all of you. In the next lecture, we will discuss something more. Thank you very much.